Good morning, Com 3928. Something looks weird, doesn't it? Completely different. I've got a wide-angle webcam I use sometime for, shooting video conferences in a classroom. No reason at all. I just thought today I'd throw this on. You can see a little bit more of where I work and something different. Thought I'd try the wide angle today. It's Friday, about 8:45 a.m. I thought I'd get started and get a jump on the video for next week because, of course, we've had a week off for spring break. Your next assignment will be due Tuesday. I'm sure by now everybody has the data completed and cleaned, correct? Everybody's run some descriptive testing, correct? Looking at some of the variables of choice and being able to report on that. In JASP, right? You've loaded JASP by now, and you use the first tab, I believe, is the descriptive tab, and the reliability testing is there too, right? So you've got your data all clean, right? We'll take a look at that in a second. I've loaded mine into JASP. I've cleaned mine up. And of course the labeling's all right, correct? You've created your coding sheet, right? You've got it all marked. You printed it out and marked all with the numbers, how the numbers relate and correlate to the different items on the survey. You have to have that to do the work, right? So you've got in there, and again, you've loaded it. It's all good. It's all clean, right? Removed and deleted. Remember, cases go horizontally. The ones where people did not fill out a bunch of it, you deleted those, cleaned that out because they didn't complete the survey. And we took out the text, correct? We lifted that out. I also told you to lift out the zip code and put that in a separate file. Please do that. If you leave the zip code in the data set, that's okay too. But you can do it either way. Move it out, leave it in. But make sure the text is out because that may mess up the testing. If you have trouble and it doesn't run, first thing I'd say is, did you delete the text out and put that in its own separate, Excel CVS, right? We save it in comma separated values, CSV files. Okay. Just think this through and work on it because I'm concerned if I haven't heard anything at all, I'm figuring everybody's perfect, right? And everybody's got this going. Please do not leave this up until Sunday night or Monday because you can get jammed up and you won't have time to fix it. These things don't always go perfectly. So please, please work on making sure that all fits together and you've got it going. If not, I want to leave time so you can contact me earlier, so that I can help you. All right? So we've got that done. So we're going to report this next time on, I think, several. Let's take a quick look at that. I think I got them both pulled up here. So this was the original assignment. And remember, we built our, cleaned up our coding, built our coding sheet, right? Got that done. I just mentioned that. I have to have the coding sheet done. Clean the data, label all the variables, right? And then, clean out the bad cases where they didn't complete it. Then give me a screen grab or a snip, of that, just a portion of it or some of it to show me that you've got it cleaned up and labeled. Okay. Download JASP. By the way, there's a brand new version out. Don't have to have it, but there's a brand new 8.6 out. If you already downloaded it, don't change. If you are behind and haven't done this yet, please do it now. There's a new version. They update quite frequently. Again, it's not always necessary. You always have the latest version, but I always do. Okay? Then remember, we go in, we hit the descriptive variables, and we report just common sense. Remember, I said look at this. You can look at sort of the mean score, but you've got to be looking at your coding sheet so you know what these numbers mean, right? For example, I don't remember what it is, but if there's 7 categories of age in the age variable, that will be between 1 and 7 on that descriptive test when you look at it, right? So it might say the mean score is a 3.4, okay? Well, what does that mean on your coding sheet? Go down between 3 and 4 and say, what is the average age of our respondents? Does that make sense? You've got to think through the numbers on the coding sheet to understand what the data is telling you, okay? So you're going to look at age, income, occupation, and relationship status. Look at the histogram. That'll show you the bars. Real easy to eyeball that and see where did they answer. Who are these people, right? And then report on that. Just simple common sense. In these 4 variables, what did we learn about our respondents? Who are they? We've got roughly 350, something like that, respondents. Who are they? What are the predominant ages? What's the average age? Income? What do most people make out of this survey group, right? So just common sense. Age, income, occupation, relationship status. Report on those, okay? Then you run the reliability test for the 8 items. That's near the end of the scale. Remember, we go way toward the end, right before the categorical variables. Like one was, if it's up to me, I would like my information on Instagram. We wrote a statement for each of 8, and then I think it's like not like me at all, very much like me. That you can identify those 8 by the way we measured it with the anchors. Okay, so among those 8, go to the reliability test. Move all 8 of those from the big box over to the right, and then hit reliability, and then you'll look for Cronbach's alpha. Right, that's telling us if it's 0.8 or higher. All 8 of those items are answered with a very similar pattern. What that tells us is they work really well together. Some people would call it a scale because they're all measuring the same construct well. That would be perception of, consumer perception of energy provider messaging. Okay, so it's just a test to tell us of these 8, are they really sort of tracking together or not? 0.8 or higher means they are, lower is not. So you'll get a number of Cronbach's alpha. Report on that. Is it reliable together or are they not reliable together? That's not a bad or good thing. It just tells you how people answered those in patterns. Okay, so we've got that for this week, and then that's coming up Tuesday, and then the following Tuesday on March 20, we're going to run correlation testing and Anova, analysis of variance. Okay, so let's jump up here into JASP. And like I said, I hope by now everybody's got the data clean, right? Label it like you want. Here's how I labeled it. Remember, this was for an energy bill. That was the first thing. We had 6 items under energy bill we asked about. Remember, the matrix went under each one. So here's energy bill, and these are all the responses. I can tell what that means. Also, this should show well in my testing when this spits out results, right? Instagram, you can see I did the same thing, those 6. Facebook, I did those 6, right? I cleaned it up down to the smallest number of words, but I can still understand what that statement was. What's that measure? Okay, so I went across and did that for all of them we tested. Remember, each one at the beginning, each one of those visuals had 6 items underneath it in a matrix. Okay, so here they all are. Remember, all of these need to have a ruler. And if you click up here like this, see this? This is continuous. And I'll try to tell you more later, but I was thinking this morning, usually when the measure is something about trying to determine the respondent's psychological response, how are they thinking psychologically with a measure, that will be continuous. And then ordinal and categorical, these are the descriptive variables. These talk about who our survey respondents were. Okay, so look, almost all the way across here, these are all rulers. These were measures through the first part of the survey, right? Here's my 8. I put these called find info. 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 here. Those are those last 8 measures I keep talking about, okay? Then look at this. Here on the end are all our categorical or, group variables. Let's call them grouping variables. How much square feet is in your home? Well, let me put this back up. For this one, I put ordinal. Ordinal categorical doesn't matter a whole lot, but think about it. Square feet is in a measure. There's an order of measure, right? Small square feet to big square feet, okay? Power bill. And I hit the wrong thing there. Think of this, I put that ordinal. Small power bill to high power bill. Remember to keep looking at your coding sheet. You're going to have to look at the coding sheet to understand what each of these mean, right? Number of people in the home. That's ordinal. There's an order. A zip code here I left in. Do it or not, okay? Occupation. That's categorical. It called it the nominal. There's no ordered occupation. You might say it, but not really. Age, there's an order to age, ordinal. Household income, there's an order. Ethnic heritage, no order. Education, order. Okay, that's how I'm setting these little measure marks up here. Okay, gender, no order. Relationship status, no order. Okay, So make sure you have all these set across the top. That's important. Okay. Then remember up here, here's descriptive. Here's the first tab, descriptive statistics. And remember I showed you how to, by the way, you can drag this open or close depending on how much you want to see. That's pretty cool, isn't it? You can just drag to see a lot of the data or drag to see the testing area. Okay. So remember this, we go down here, we hit age and move that over into the box. And here we will see, it's running some stuff right now. And let's see, I'll put frequency tables. That's important because it shows us, again, what are these categories? You've got to look at the coding sheet. Each one of these numbers represents an age group that we have. Okay, here's the frequency, here's the percent of that one. We can go real quick. Whatever number 2 is, whatever that age group was, that is the most predominant. 21% of the respondents were in group 2, right? Second most would be this one, 15% are in group 5. So just common sense, think about what groups represent what parts of who are these people? First is age, okay? And then look at distribution plots, click on that. This gives you a great eyeball. Right here you can see again how many answered for each of the categories, okay? So you run those and just report on that. Run the ones I told you to do and report on that, okay? Easy, and then remember under descriptive here, reliability analysis was the other test. And again, down here, I'm not going to run this one, I want you to do it, but remember, take the 8. And here were my 8. I called them all find info, but they're the 8 at the end that measure the 8 different types of messaging that people prefer. Click this over here, that will give you a Chromebox Alpha. You test that. Okay, so that's what we're doing on that. So we did that. Now let's look at this. Now correlations in Anova testing. Okay, this is where, remember those 8 items we just tested for reliability. Now we're going to say which of those 8 items pair together. That tells us a lot. Of those 8 items, which ones correlate together. Okay, in this type of work correlation, one thing we have to remember. We never know causation. We can never say one causes the other to happen. We never do that in research. It's impossible. We say there's a relationship between the variables, okay? If it's a positive relationship, when one goes up, the other goes up. When one goes down, the other goes down. Depending on the strength of the relationship, they move together. If there's a negative relationship, and I can show you if we get any, that means when one goes up, the other goes down. When one goes down, the other goes up. The relationship is there, but it's opposing. Positive or negative relationships. That's what we learn in correlation. Okay? So if we jump back here, I think it's in regression correlation matrix. Regression correlation matrix. Okay? We're working with the same 8 again. Those 8 measures for the different types of messaging. So I'm going to move all these 8 over. And by the way, it's checked here, Pearson and report significance. Those are the only 2 you needed checked, okay? And then I'm going to move them over. This is called a correlation table. And I'm showing you the answer here. Here's what's important. I want you to look for one. This looks a little complicated, but again, these are all the pairs. If you go Instagram web page, look at over and up. U.S. Postal energy bill. Over and up. Keep looking at which ones are together. That's what you have to learn on the table. It can be complicated at first. U.S. Postal web page. So as you go, the first thing I do, just scan. Remember, the p-value is the significance of each pair. Now, there's quite a few that might be significant. I want you to look for those that are the most highly significant, less than 0.001. Okay? Less than 0.001. Here's even 0.001. Don't worry, for this case, for this study, let's report on those. So for each of these, let's look, just scan down, scan across. Make sure you look at every pairing. Here is this is very significant. I like to find info by email, and I like to find info on the web page. Now, next after we see that's significant, then look at this Pearson's R. That tells us the strength of that relationship. It goes from 0 to 1, okay? So we know this is significant pairing. Now we know it's a 0.22, not too bad. But it's important to report a test is highly significant, less than 0.001, and what the Pearson's R is. That's the strength of the relationship, okay? So we know here when highly significant, when people like to look for things on email, they also like to see things on the website. Up and down, they work together. Now that tells us something about a group of people, doesn't it? There's a group of people in our survey, they correlate those two together. People that like their email messaging probably like the web page messaging. That tells us something for advertising purposes, right? When we message, we have to know how people are thinking. That might affect our messaging, right? So let's look across. I'm going to show you one that's important. A lot of these are positive, right? So you'll see, find U.S., I like U.S. Postal, and I like it on my energy bill. Does that make sense? I like it in the mail. I like it on the energy bill. People that like hard paper in their hands, okay? That's 0.32, highly significant, less than 0.001. Medium, pretty powerful, 0.33 that comes up to. That's pretty good. So we know that one works well together, okay? I'm trying to see, now here is one I want to show you negative. See, this is a negative Pearson. I want to show you why. Now, it's still highly significant. We know that find info via text and find info U.S. Postal, they're significant, but guess what? Look at this. Negative 0.21. 205 becomes 0.21 negative. Remember what I said? They move against each other. So people who like info on text don't like U.S. Postal. Makes sense, right? When people want more text, they want less U.S. Postal. When they want more U.S. Postal, they want less text. Those two work away from each other. They're negative. So it's really important to see not only that something's significant, but also if it's positive or negative. Okay? So for that, remember to report on the correlation, pull up the correlation table on those 8, okay? Then look at less than 0.001, highly significant, find those pairs, mark them, do whatever you need to do, and then report, is it a positive, or report the Pearson's R, and then what does that power mean? From 0 to 1, is it strong or not? Report the Pearson's R, and then is it positive or negative Pearson's R, which tells us they're working together, or negative, they're working against each other. Important for advertising. These are inferential things we learn from data. Tells us how these people are thinking, how their perceptions work together or not in these pairs. Okay, so I even showed you some of them. That is the test, right? So I'm showing you exactly what you're going to see. If you don't see something like that, you have trouble. Okay. So now let's go back here, and then the next thing, you do that and report on it, right? The information is here, and then the next thing we're going to do is important. Anova, analysis of variance. This tells us is among the different groups, like, for example, among age groups related to Instagram, is there a difference? The different age groups respond differently to Instagram, okay? Is there a significant difference among the groups? Now watch, this gets a little more complicated, but I'm going to show you how to do it. For this test, we're going to use the Instagram variable. Remember, again, I'm going back, call it the big 8. Those big 8, the ones that measure the 8 different types of messaging. I'm going to take out the Instagram one. Remember, that's a continuous variable with the ruler. I'm going to put that in as the dependent variable. That means we're testing against that. Okay? And then we're going to test 3 important categorical variables against Instagram. We're going to test how many square feet are in my home, number of people in my home, and monthly power bill. 3 different important things regarding power provider. Are they different based on how people look at Instagram? Okay. So I'm going to go back into my JASP, right? And now I'm going to go Anova, pretty easy, right? We're going to go to Anova, analysis of variance, right? So I said, remember, we go back down here to the big 8. Mine are called find info. That's how I labeled them all the same. So we're going to go Instagram dependent variable. Okay, it even shows you it has to be a ruler. It has to be a ruler. That's important. Okay, let me check something. I got it. Okay. Then here one by one, not all together, one by one, you're going to test square feet, power bill, and people in the home. Each one of those is a separate test, so start with square feet. Notice here too, you've got to have the ordinal or nominal. It even shows you what icon you have to have in this box. Makes it helpful, right? So I'm going to move over square feet, okay? And it's running that, by the way, then go down here, let's see, simple, additional options. Go to additional options, see where it says estimates of effect size. Click that, okay? So we run the test up here. First thing to do is go down under additional options and click estimates of effect size. Follow me through this, there are some steps. Okay, guess what? The first thing we look at is the p-score. This is the significance of the test. It has to be less than 0.05. It has to be less than 0.05. What is this one? Is this less than 0.05? No, it's actually 0.2, right? This is not a significant test, okay? Against Instagram, this is not a significant test. So we move square feet out. We don't even have, all we have to do is report there it's not significant, which means based on Instagram, square footage of house, those people are not different. No one, those different groupings of the size of square foot of the house, that didn't matter to Instagram. We don't think there's any difference there, okay? So then I go to Power Bill and click that one, and that one too is not significant, okay? Now, I'm going to go back and click, let's see, number of people in the home. There we go. So I'm showing you how to do this, okay? I'm showing you the first two are not significant. There's no differences among the groups, okay? This one there is. Based on Instagram and the testing in this data, the number of people in the home may affect how people perceive Instagram messaging. Sometimes it's hard to understand how that works, but the data is telling us that, okay? So there's some things to look at, okay? The first thing is it less than 0.05? Yes, this is a significant test. Then we look at this is the effect size. It's really, okay, effect size 0.01 is weak, 0.05 is a medium effect size, and then closer to 1 is a real strong effect. Effect size tells us what's the strength of those differences. Is it really strong differences or not so much weak, okay? This is actually comes up to a 0.4. This is a medium effect size. There's medium strength in this test. That's pretty good. So we know based on people in the home, number of groups of people in the home, and Instagram, there is a medium effect size, so you report that as significance at 0.01. Actually, that's 0.02, right? We round up. We usually go 2 past the decimal, 0.02. All right, we don't go 3. We usually report on 2. And then here, medium effect size, we look at those two. Okay, once we have significance, and once we report significance and effect size. Remember, we only have to report if it's significant. If it's not, we just say that test wasn't significant. That's okay. Then we go here where it says post hoc. Click on that. Here is the variable. See where it says people in the home? Click this and move it over to the other side. Post hoc. This is going to run. This is where a lot of students get messed up. This shows us every combination of pairs among those groups. Okay? So based on the number, remember, you got to go back to the coding sheet here. You've got to look at the coding sheet. This is looking at number 1 and number 2. Well, what are those groups on the coding sheet? This is 1 and 3, 1 and 4, 1 and 5, 1 and 6. These are all the possible pairings among the groups, okay? 2 and 3, 2 and 4, 2 and 5, 2 and 6. These are all pairings, okay? So you've got to look across each combination here. It's almost like correlation, but you've got to do that. Here's what's important. All you need to look at for this, see this P2 score. This is going to show us, now that we know the test is significant, which pairs are significantly different. Which grouping pairs? Just scan down P2. What do you see? I'm not going to go further here, but it has to be less than 0.05, just like the significance. You'll scan down here. If you see less than 0.05 under P2 that will, look what pairing that is. Look on your coding sheet. Those two groups are significantly different. Okay. Report that for every pair that shows up as P2 less than 0.05. Report on that pair and then make a practical application. If we know those two groups are really different regarding Instagram, based on number of people in the home, how might we do our advertising messaging when we're talking and relating to customers regarding Instagram or on Instagram messaging? Is there a difference among groups, how we report to people or communicate with them? Okay. So, wow, 25 minutes. So for this time, remember, you've got things coming in Tuesday. You've got clean data coming in. You've got, your variables set properly up here, right? You've got descriptive testing coming in, talking about some of who is our audience, reporting on that, right? You're going to run a reliability analysis on those eight statements that measured each type of messaging. You're going to report on that. Is it reliable? Chromebox Alpha. 0.08 or more is significant or is a reliable test, less is not. What happened? Report that. Is it a reliable 8 together or not reliable together? Again, that's not a bad thing. It's just telling us the pattern may all work together really well or it doesn't. Okay. Then we're going to go into the next week. That's coming up next Tuesday. That's going to be the correlation testing. Remember, we're looking at the power of the pairs. As we look at those 8 again, all the combinations of pairs among those 8. Right? Which ones are significantly correlated? Are they positive correlation, negative correlation? Report the p-value, less. In this case, I want you to report less than 0.001 and report the Pearson's R. That's the power of that relationship among the correlated pair. It tells us things. Think about it practically. What does it tell us? Then analysis of variance, Anova testing. You're going to go in, and I'm giving you just one example. There's many, many more for the final project. You're going to want to test all of them. I'll show you. There's a lot of combos. It doesn't take long. Once you know how to do it, you're clicking them in and out of there in 5 seconds. A lot of them aren't significant, but you've got to test a lot. We're going to test just one to practice, okay? We're going to look at Instagram, dependent variable, continuous, ruler. It's got a ruler on it, right? And based on how people view Instagram messaging, we want to look at the different types of square footage in the home, the different types of power bill, and I believe it's the different number of people in the home, power bill, and what was the other one? 1 second. Let me go down here and check once. People in the home, power bill, and square feet. Square feet, power bill, and people in the home. Okay? So we test all 3 of those against Instagram and find out, are the tests significant? Which ones are not? Remember, if it's a not significant, just report it's not and then move on. If it's significant, we got to look at the p-score, p-value. We got to look at the effect size, strength of the relationship. And then we have to look at the chart after we move over the post hoc. So it shows us that big table of all the combinations of the categories and look down P2 are any less than 0.05. Report on that. Also, I think in the assignment I said put in some screen grabs, snips. Show me your data's clean in that one assignment. Show me, I think the new assignment, the correlation table. Show me a portion of it that you ran it correctly. Screen grab one of your tests with P2 I'd suggest the significant one for Anova. Okay? And again, think practically. That's what this is all about. What are we learning about people, power providers, their messaging, and how our data set, our consumers that took our surveys, how are they looking and thinking about this? Okay? So that's it. I'm taking you right up to 30 minutes. I appreciate it. And I'll be in touch. Please work ahead on this stuff. Sometimes you get jammed up a little bit and you need to get past that. All right. Thanks a lot. Bye.